graph the equation y equals 1/3 x minus 2. And we are seeing that it is in slope-intercept form, but what is slope-intercept form? Slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. Every time we have an equation in slope-intercept form and we want to graph it, we always start at the y-intercept. Well, what is the y-intercept? The y-intercept is where it crosses the y-axis. It's when our x is 0. So our y-intercept here is -2. So we're going to start at -2 on the y-axis. So we go down, 1, 2, and we put our point. Then we have our slope. Our slope here is 1/3. And the slope is the rise over the run. So how many we're going up and how many we're going over. So the 1 tells us that we're going up 1 and 3 over. Because this is positive, we're going to be going up 1 and 3 to the right. And why does that make sense? As we go up and to the right, we see that the x values are getting more and more positive. We want our x values to get more and more positive. Our line is going to get more and more positive. So we're going to go up 1 and over 3 to the right. 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Because I have no more room on my coordinate plane, I'm going to stop. Now, we want to continue this line. Are we going to go down and to the right, or are we going to go down and to the left? Well, if we go down and to the right, we're going to have something looking like this. That's not what we want. We don't want that. So we are going to have to go down and to the left. So I go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Is this a line though? No, these are just a set of points. So we need to have a line. So we're going to connect a line through it. And we need arrows. This line continues. Just because our coordinate plane stops does not mean that our line is done. Our line continues on forever. So let's try another problem. For our next problem, we have y equals -4/5 x plus 5. So we're going to do the same thing we did before. The only difference here is that we have a negative slope, a positive y-intercept. Well, let's start at that y-intercept. So we're going to start at +5. So we go up 1, 2, 3, 4, 5. Now, just like before, our slope is telling us that we're going to go up 4 and over 3. But because now that it's negative, we have to go up 4 and to the left 3. So we're going to go up 1, 2, 3, 4 to the left 1, 2, 3. I have no more room, so I'm going to have to go down, like we saw before. I'm not going to go down into the left because that's not going to create a straight line, and we want a straight line. So I'm going to go down and to the right. So down 1, 2, 3, 4, over 1, 2, 3. Down 1, 2, 3, 4 to the right 1, 2, 3. And down 1, 2, 3, 4 over 1, 2. And just like before, we can't just have a set of points, so we're going to have to connect our line and put some arrows on the end. We try to make this as straight as possible. Really, I miss this point. Fix that. Let's try one more example where we don't have a fractional slope to see what happens there. So now we have y equals -2x minus 1. So we know with that -1, we can just plot that. That's our y-intercept. That's going to stay the same. So put a -1 here. However, now we have a slope of -2. Well, -2 is not a fraction. Wrong. -2 can be written as a fraction. That could be written as -2 over 1. So we're going to go up to 1 to the left. Up 1, 2 over 1. Up 1, 2 over 1. 1, 2 over 1. And we keep on going. Once again, because we went up to the left, we're going to go down and to the right. So down 1, 2, pull over the right one, and keep on going. And we connect our line. So this is how we graph equations in slope-intercept form. We always start at the y-intercept. It's important to know what is the y-intercept to start there, and then we use our slope to tell us how many we're moving up and over.